Okay, this is topic 46, relating f of x, its derivative and its second derivative. So notice that below we have the graph of the derivative, all right? So this graph is the graph of the derivative. So just to remind myself, I'm going to write f prime of x so that I'm not making mistakes. So question number 1 is asking to name the intervals on which function f is increasing. So notice that again, we're talking about function f. This is not function f. This is the derivative of the function, all right? So remember that anywhere on here where the derivative is positive, so remember the derivatives are positives right here above the x-axis. Right, where the derivative are positive, that's where function f is going to be increasing. So again, this is something that we have talked about in the past. So again, this is going to be increasing between negative infinity and negative 2. All right, and the reason is because the derivative is positive or is greater than 0, right? That's the reason why f is increasing. Now, we wanted the intervals on which f is decreasing. So for the same reason, if you're below this x-axis, every point on here represents a slope of the tangent line, which means if you're below the x-axis, then all the derivatives are negative here. Okay, so the intervals in which f is decreasing, would be between negative 2 and 0 and positive infinity. Again, notice that at 0 you have a derivative that would be equal to 0. Okay, so the reason for this is because the derivative is negative. Okay, the relative extrema, right? So the relative extrema is going to be located where the derivative changes sign. So notice that right here, at this point right here, you have a relative max because you went from positive slopes or positive from a positive derivative to a negative derivative. So right here you have a maximum. So we have a relative max at x is equal to negative 2 because f prime of x changed from positive to negative. Okay. Again, notice that on this one we don't have a minimum. Right here we have another horizontal tangent line located right at this root. But because I didn't switch from negative to positive, and therefore this is not a relative extrema. This is not going to be a minimum or a maximum. All right. Now, question number 4 is asking us for where is function f concave up. So remember, to figure that out, we need to figure out this is going to be concave up. Remember, if the second derivative is positive, right? So if the second derivative is positive, then that's going to be concave up. Well, the second derivative is going to be positive anywhere where this graph, the graph of the derivative, is increasing, right? Because when it's increasing, you have positive slopes. And if you have positive slopes here, then you have a positive second derivative, all right? So right here, this little part right here, I'm increasing. So if this part you're increasing, that means that on the original graph of f, then you have concave up. So concave up is going to be between negative 1 and 0 because f prime of x is increasing. All right, where is f concave down? So function f is going to be concave down anywhere where the derivative of this function is negative. Now the derivative of this function being negative implies that you're going to be decreasing. So notice that you're decreasing between negative infinity and this point right here, and between 0 and positive infinity. All right, so again, between negative infinity and negative 1, and 0 and positive infinity. Okay, and this is going to be because the derivative is decreasing, and if the derivative is decreasing, that means that its second derivative would be negative. All right, so that's that for that. All right, now we're going to talk about points of inflection. Now this one right here, the points of inflection are where you switch from positive to negative, all right, when you go from increasing to decreasing. So notice that right here right here at this point and right here at this point. All right, so I'm going to draw a little star maybe. That'll be more clear. At those 2 points, the first derivative changed from negative slopes to positive slopes right here. All right, so again, the points of inflection in this case are going to be the max and mins right here. So the points of inflection are going to be at -1 and 0 because f prime of x changed from increasing to decreasing or decreasing to increasing. Again, notice that because right here on the derivative I'm decreasing. I went from decreasing to increasing, so that will make this a point of inflection. And the same idea on this, because I went from increasing to decreasing, that point right there would be another point of inflection. All right. So now in this one we're going to sketch the graph of the function. All right, and notice that it's actually giving us more information. It says that the only zeros at a -4 and 0. So I have to keep that into account. So I'm going to have a point here, 3, 4, and I'm going to have another point right there. All right, so we have -4 and 0. So I have to have those. Now again, it's really up to you if you want to do this. However, I am going to do this for myself. Notice that I switched to pencil. Mistakes could happen. I'm going to do some sign analysis on the derivative. So notice that I went from, let's see, -2 here, positive right above the x-axis. Then notice that I'm negative here, and then negative here. All right, so that's the way my derivative function looks. My second derivative. See, I'm going to put my points of inflection. I have one there and one there. Notice that on this one, I'm actually looking at where am I increasing and decreasing. Right, so I'm decreasing between -∞ and 1. So this is going to be negative, which I'm going to write negative, but remember this is down. So it's concave down. And then after that, I'm going to be concave up. So I'm going to write up here. And then after that, I'm decreasing, which is going to be concave down. Okay, so just kind of remind myself. Okay, so now, again, I'm going to plot those points on here just to remind myself. So I have -2. Notice that at -2, I have a maximum. So I'm going to write that here. I have a maximum. Let's see, at -1, I probably should have spread this out a little bit more, but at -1, I have a point of inflection. Okay, and then at 0, I have another point of inflection here also. Okay, so I have another one that kind of runs through here. Okay, and that's pretty much it. So notice that at first, I am going to be increasing. All right, so I'm increasing in concave down. I have to go through that point. All right, so I'm going to go through that point. I'm increasing. And then this is my maximum, right? Then after that, I'm going to change concavity. Excuse me. I am not going to change concavity. Like I said, mistakes could happen. I'm going to change concavity here at -1. Right, but notice that I have to go through this point, right? So I have to make this happen through that point. So it's going to go through that point right there. And then after that, I'm going to switch concavity because I have a point of inflection here. And I'm going to be decreasing. So I'm decreasing basically from -2 all the way down there. Right, so I'm going to change that and just keep going down. All right, so that's how you graph that. Okay, so let's go to the back now. The back, it's different because now this one is the graph of f of x. All right, so this is the graph of f of x now. Okay, so this, at least this part is going to be easy. It says the interval at which f is increasing. Well, there's no tricks here. All right, I'm increasing between -∞ and here. And I'm also going to be increasing between here and here. Okay, so again, this is the graph of f, so there's no tricks here. You just look at it. Okay, so you see that it's increasing. So There's not really a justification needed for this. Again, notice that I got that 3.5 because that's this little maximum right here, this relative maximum right here is at 3.5. Okay, so the intervals at which f is decreasing, all right, so I'm decreasing between here and all the way down here. All right, so that's going to be between -3 and 1. Okay, that's one of them, and I also have another one. I'm decreasing between here and down here. All right, so -3 and 1 and 3.5 and positive infinity. All right, my relative extrema, well, my relative extrema are going to be located here, here, and here. That's easy, right? So I guess I should write relative max here at x is equal to -3 and 3.5. Again, those are my maximums right here. I have a minimum right here at 1, so I have a relative minimum at x is equal to 1. All right, where is this concave up? Well, it's concave up basically right here, between here and here. Can you tell? All right, so right here I'm concave up. So between -1 and 2.5. All right, now it's asking for where am I concave down? All right, concave down is going to be all of this, all the way till about here. Because see, right here you're switching concavity. All right, and I'm also going to be concave down between here, this point right here, and all the way down to infinity. All right, so I'm going to be concave down between -infinity and -1, right, which is that point right there. And I'm going to be concave down also between 2.5, it looks like, and 2.5 and positive infinity. So between 2.5 and positive infinity, right? Because it keeps going down like that. All right, so the points of inflection is where you switch concavity. All right, so you can tell my points of inflections are going to be right here. My point of inflection are going to be here and here, right? So x is equal to -1, comma, 2.5. All right, so that was easy, right? Now, the part that it's been a while since we've done this is how to graph the derivative function and the second derivative. Well, we've done this before. We haven't done that before, but it's actually the same idea, right? So what we're going to do here is we're going to do our sign analysis for the first derivative. Remember, and where I'm putting here, what I'm putting here is my relative extrema. Okay, so we have that, this, and I don't know, let's call it 3.5 here. Yeah, I gotta keep going. All right, so that's my relative extrema. Now remember that what I'm gonna write on here to figure this out is like, all I have to do, remember I have one, this is gonna be positive, right? That's gonna be positive. If this is increasing, if f is increasing, that means that the derivative is going to be positive, right? My f prime of x is gonna be positive. Now where I'm decreasing between here and here, that's going to make those slopes negative. And where I'm increasing between here and here, that's going to be positive. Right, that's going to be positive slopes. There will be positive tangent lines all the way across this curve. And then finally between 3.5 and -infinity, notice that you're decreasing, and if you're decreasing, all the tangent lines on every point would be negative. Right, and again, I kind of have that written down over here, but I'm just making you rethink about it anyway. So now I'm going to use that to graph my f prime of x function. Right, so again, what I want to do before I start is I want to put my max and mins on here. And now something that you may not remember is that what you may not remember is that where my maximums and minimums are located, right? My maximum and minimums, those are actually going to be my roots. Those are going to be my roots on the derivative function, okay? So those are actually going to be my roots. So again, what I'm going to do here is I'm going to start, remember, this literally means I'm going to be above the x-axis, right? So I'm not going to start here. I'm not going to increase. I'm actually going to be above the x-axis. Right, and after I go through -3, well, my derivative function is going to be negative, meaning I have to be below the x-axis. All right, so I'm going to keep doing that, and then same idea here. After 1, I'm at positive, so this is going to be positive. So just like that. Remember, this has to be 1 degree less, right? This has to be 1 degree less than that one. Okay, so, and remember, because this is kind of a negative, this is also going to be a negative, right? This is even, that's going to be odd. Okay, so just little things you can check, but this is the same idea, right? So this is the general idea of it right here. All right, for the second derivative, well, for the second derivative, I have to, well, I don't have to, but I'm going to. I'm going to do some sign analysis for the second derivative. But instead of putting I'm going to put my points of inflection here. Remember, this has to do with concavity, right? So where the concavity, this is concave up, that's going to be positive. Right, where this is concave down, that's going to be negative. Negative here, negative here. I should have used a different color. But so here's the idea, right, with those three. Remember, yes, that means concave up. Those will be concave up, concave down, and you can see that here. Concave down, concave up, concave down. All right, so what you're going to do on here is that now my points of inflection are going to be my roots. So -1, and this is 2.5. This definitely takes some getting used to, right? But think about it. Before I even draw anything, right, this is going to be a cubic function. So if 1 degree less than that was going to make that a quadratic. Okay, so on this part right here, I have to start down here because this is negative. Okay? Then I have to go through that root. And I keep going. And I'm going to be positive all the way until I get to 2.5. And after 2.5, I have to be negative. So that'll be the graph of the second derivative. Okay, so this is kind of working backwards from what we have done so far. This homework can be confusing. So if you got any questions, please let me know. Take your time on this.